Okay, let's take a look at 10-1, the beginning of equations of circles. And here we have a circle, and notice that the circle has a radius of 10, which is why the circle hits 0, negative 10, 10, 0, 0, 10, and negative 10, 0. The first question in 10-1 is, what do all of the points on the circle have in common? That is, what is true about every single point on the circle. So every point on the circle is 10 units away from the origin. Makes sense because the radius is 10. Okay, so every point is related to that radius, that distance. Okay, next question. B, determine all of the points on the circle where x is equal to 6. For each point, what is the y value? And then it says to use the right triangle, like the one shown at the right, to justify your answer. So we want to know what points are there when x is equal to 6. Well, if x were equal to 6, I would end up with 2 points. One would map above the x-axis and one would map below it, okay, because there's 2 points on the circle where x can equal 6. So then it asks, well, what would y be when x is 6? And it gives us a hint, and it says to look at this triangle. Now this triangle right here is a right triangle. This is a horizontal and this is a vertical. So when they intersect, this is a 90-degree angle. And so we have a right triangle here, and we can use the theorem that relates all the sides of a right triangle, which is Pythagorean theorem. We know that the leg squared plus the leg squared equals the hypotenuse squared. So we're going to use that to find y when we know x is 6. So when x is equal to 6, in this right triangle, so forget about the circle for now. Let's just focus on that triangle. When x is equal to 6, we know that we can use the Pythagorean theorem to find a missing side. And we want x to equal 6, so that's one of these legs, A or B, because C is the hypotenuse, that's the longest side. That C is reserved for 10. So 6 can go in for A or B, so I'm going to put 6 in here for A, plus B squared, which was the y squared, and 10 squared, which will represent the hypotenuse squared. Okay? So in the right triangle, I should really just put the y squared here because that is the other leg squared. Okay, so we have entered in the 2 sides that we know into the Pythagorean theorem, and we're going to solve for the third side, which is the vertical leg. Okay, so we get 36 plus y squared equals 100. And then when we subtract 36 from both sides, we get 64. So y squared is equal to 64, and when we square root that, to undo the square, we end up with 2 roots, plus or minus. We get y is equal to plus or minus 8, because we know that 8 times 8 is equal to 64, and also negative 8 times negative 8 is also equal to 64. So y is equal to 8, and that is our verification that when x is 6, y is 8, or when x is 6, y can equal negative 8. Okay. All right, that is B. And then C is asking us for what if x is equal to 3 for each point on the circle where x is equal to 3, what is the corresponding y value? And then again, it asks us to use the right triangle to justify the answer. So we can do the same thing here. X is equal to 3, put it in the Pythagorean theorem. This time we're going to let x equal 3, so that's one of the legs. The other leg, which is the y, So y squared equals, and then the hypotenuse is 10, so we got 10 squared. And then now we can solve for the y, the other leg. So 9 plus y squared equals 100. Subtract 9 from both sides. Y squared is equal to 91. When we square root that, to undo the square, we get approximately 9.5. And you can put that into your calculator. You get approximately 9.5. So we know that when x is 3, oops, we need a plus or a minus. So when x is 3, y is 9.5. So here it would be maybe 3 right here, and then 9.5, or 3 and negative 9.5. 3, negative 9.5. Okay, so B and that's C. Okay, and then 10-1D asks us to, well, it says Mia picks a random point on the circle and labels it XY. Okay, that's here, XY. And unfortunately, she does not know a value for X or Y. Help her write an equation that relates X, Y, and 10. So what is an equation that relates X, Y, and 10? Well, the relationship between these sides can be related through the Pythagorean theorem, because it says that a leg squared plus the other leg squared is equal to the hypotenuse squared, or in this case, the radius squared. Okay? All right, and that's D. Okay. Does your equation from part D work for 10, 0, 0, 10, and -8, -6? So we're going to test to see if some points live on the circle by entering the points in for X and Y. I've already done that. So if you take a look at the first point we're going to check, 10, 0, you can plug it into the Pythagorean theorem. 10 for one leg, 0 for the other, and then the hypotenuse squared would be 100, and it works out. Checks out that 100 plus 0 equals 100, and so this point is a point on this circle. Okay, the next one is 0, 10, and if you plug it into this equation, which is the equation of the circle, you'll get another true equation, which means that 0, 10 is also on the circle. And then if you check -8, -6, enter it into the equation of the circle, you end up with the two legs being entered in, then getting squared, and then getting totaled together to still equal 100, which checks out that this point is also on that circle. So this, in fact, is a good equation for the circle. Okay, you can check to see if any point is on the circle by doing this, or you can check, or you can solve for an X or Y if you have a corresponding X or Y.